guys, here are the notes for section 9.4. You can see this is our last transformation that we're going to do. It is called a dilation. And a dilation is when you take a figure and make it larger or smaller by using a scale factor. So what we want to do is we want to be able to perform a dilation, and we want to be able to calculate what a scale factor is, or what the scale factor is. Let me give you a really easy one. I have a triangle here, which I will call ABC. I guess I made it a right triangle, though that's not a big deal. And this will be A prime, B prime, C prime. And you can see that one triangle is bigger than the other one. Let me put some measurements on here. This one will be 3, 4, and 5. And this one will be 9, 12, and 15. So probably you can see already that triangle ABC was multiplied by 3. All right? 4 times 3 is 12. 5 times 3 is 15. All the measurements in the first triangle, ABC, were multiplied by 3. So, we say this is a dilation. There we go. This is a dilation, and since it was multiplied by 3, the scale factor is 3. That right there says scale factor. I'm not going to fix the board yet. So there's your first example of a dilation. We made the triangle bigger. All right? This, of course, would be the pre-image, and this would be the image. So we took the pre-image, which is the beginning shape, and we made it larger by multiplying everything by 3. And the thing you're multiplying by is called the scale factor. Let's look at a second example, and I will quickly fix the board before I do it. Okay, so ABC is multiplied by a scale factor of 3. What are the coordinates of A prime, B prime, C prime? So on a coordinate plane, the way this is done is first we're going to want to find the coordinates of doggone it. Find the coordinates of the pre-image and multiply them by 3. It takes a real talent to write on this board. So I'm looking over here at the pre-image, and I notice that point A here, point A is at the point 0, 0. Maybe I shouldn't be too proud of my talent yet. Maybe I should just go to doing this on paper all the time. Point B right here is at 2, 3. Suddenly the board is fixed. And point C right here is at -3, 2. So these are the coordinates of the pre-image. And I'm going to take each of these coordinates and multiply them times 3, since 3 is the scale factor. And that is going to give me A prime. Well, when you multiply 0 times 3, it's still 0. And when you multiply 0 times 3, it's still 0. So A prime will still be at 0, 0. B prime, when you multiply the x coordinate times 3, you get 6. Oh, man. And when you multiply the y coordinate times 3, you get 9. And then last up, we've got C prime. When you multiply the x coordinate times 3, you get -9. And when you multiply the y coordinate times 3, you get 6. So those are going to be my image points. And let's go ahead and graph the image. So A prime is still going to be at 0, 0. B prime is going to be at 6, 9. And C prime is going to be at -9, 6. And I will reconnect the triangle. And you can see that the triangles actually overlap each other some. The red triangle and the blue triangle make a dilation. All right, the red triangle is the image, the blue triangle is the pre-image, and the red triangle is 3 times bigger. Next example, we want to look at how do you calculate the scale factor. All right, what is the scale factor? Let me tell you how to do that. Find the scale factor by taking any image point and dividing it by the corresponding pre-image point. All right, so I'm going to take a image point and a pre-image point. The pre-image point I use is going to be point C, right there. And the image point I use will be C prime, right there. So let's look at the coordinates. I want to do the image point, that would be C prime, divided by the pre-image C. Well, C prime is at 10, 2. And C is at 5, 1. I do not need to divide both the x-coordinate and the y-coordinate. I can just pick one. And obviously 2 divided by 1 is easier here, so I'll use that. This is going to be 2 divided by 1, or just 2. I have now found the scale factor. It's 2. Oops, the scale factor. There you go. All you do is take the image divided by the pre-image to find the scale factor. All right. Let's look at a couple more things and we're done. All right, first of all, we have this word congruent. So a lot of people think congruent means equal, and it kind of does, but not exactly. The symbol for congruent is an equal sign with a little squiggle on top of it. The definition of congruent means having all equal measures. All right, so two objects, like two triangles, where all their measurements are equal, we say that they're congruent. All right, only measurements are said to be equal. Figures are said to be congruent. You would never call two figures, like two triangles, equal to each other. You would only call them congruent. And that's if their measurements are equal. Let's see. I think I have one more thing. Figures are congruent after any series of transformation. This should not be transformations. Hopefully I changed that. Translations. They are congruent after any series of translations, reflections, or rotations. They are not congruent when you do a dilation, but they are congruent if you do any of these three. There are three things you should be able to do when you do a translation, a reflection, or a rotation. One is, can you name the congruent figures? And by that, I mean, can you pick out the corresponding parts and name them? And can you name them in the correct order? For instance, if I had two figures, and we will call those, let me draw a couple figures over here. We will call those there and there. We'll call this A, B, C, and we will call this one A prime, B prime, and C prime. And hopefully you recognize that this is a reflection, and this line is my line of reflection. So B reflected to B prime, C reflected to C prime, and A reflected to A prime, right? When I name two figures, I have to put their letters in corresponding order. So when I say that they're congruent, if I say the first one is triangle ABC, when I name the second one, I have to say A prime first, so that the corresponding parts, A and A prime, come in the same order. I have to say B prime second, so that B prime matches up with B, and I have to say C prime third, so that C and C prime match up. The names must be in corresponding order. Now that's easy when you're using prime notation, but if you're using different letters for the two, it can be more difficult. Next up is parts. Well, right here. Can you name the congruent parts? So the parts would be like this. A triangle has 6 parts. In this case, you'd say that AB is congruent to A prime, B prime. You'd say that side AC is congruent to side A prime, C prime. And you'd say that side CB is congruent to side C prime, B prime. I have named all three corresponding sides equal. I could also do the angles. I could say angle A is congruent to angle A prime. I'm going to skip that. And the last thing that we have not talked about is this, orientation. orientation is whether, spelled that wrong, can't have that. Terrible. Whether you name a figure clockwise or counterclockwise. And I want you to notice something. The triangles listed above here, triangle A, B, C, when I name triangle ABC, which direction am I going around the triangle? I'm going clockwise. Right? I start at A, and when I go down to B, I'm going clockwise. And when I go to C, still going clockwise. However, when I name triangle A prime, B prime, C prime, I start at A and I go this way, and I go this way. That's counterclockwise. A prime, B prime, C prime has a counterclockwise orientation. So these two triangles have a different orientation. It doesn't really matter how you name the triangle. The important thing to notice is that when I name one of these, the other one has the reverse orientation. And that is always going to happen when you have a reflection. A reflection will always switch the orientation of the letters. All right, that's all. Good luck.